Good morning, class, and welcome to this lesson on Circuits 11, Combination Circuits. Today we will be able to solve for voltage, current, resistance, and power in a combination circuit. So what is a combination circuit? A combination circuit is a circuit that has a series component and a parallel component. Okay, so there's going to be some series and parallel in one circuit. Okay, now with a combination circuit, it is very, very important that you know all your rules for series and all your rules for parallel because it is very easy to get them confused. So you have to make sure that they are all lined up very nicely. So it's just going to be through a lot of practice that you get this down, okay? So the first thing we're going to look at is equivalent resistance, equivalent or total resistance, okay? Remember for parallel, our equation was 1 over R equals 1 over R1 plus 1 over R2, etc. And in series, it was R1 plus R2 equals resistance, etc. Okay? So, equivalent resistance. In order to find the equivalent resistance, we have to break down a circuit into its series and parallel components. So, if you look at this example right here, we have a circuit. We have a circuit. We have this 110 that's in series with all these three then these are all in parallel, okay? So we have to break it down piece by piece. First, we look at these two resistors, 220 and 250. These two are in series. So let's add these together and write it like this as a 470 ohm resistor because in series we add them together so we can just treat these as one resistor. Because those are in series. So now we're going to take this picture, move it down here. We notice that with the 180 and the 470, these are in parallel. And when we solve using the parallel equation, we find that these two have the equivalent resistance of 130. So we can just basically we can take this whole thing and write 130. Now we notice, we bring this down here again, that the 110 and the 130 are in series, and in series we add them up. So the equivalent resistance of this circuit right here is 240. Okay, 240. So notice how we had to break that down into its series and parallel components. So that's what we're going to be doing, okay? And there is no rule. There is no way I can say add these first and do this second or do this third. You just have to have a feel for it and understand, and you'll get an order. So here's an example of a combination circuit. This 12 and 6 ohm resistor are in parallel, and they are in series with a 4 ohm resistor. So we are going to solve for all the things we solved for already. Okay, so here we go. We are going to solve for equivalent resistance first. Okay, equivalent resistance. So we can't add these together yet because they have to be in series to be added together. So we have to look at this first, okay? So our equivalent resistance of this part right here is going to be 1 over R equals 1 over 12 plus 1 over 6. Okay, our common denominator here is 12. 12 goes into 12 one time, 6 goes into 12 two times. So when we get this, we get a resistance of 4 ohms. So if I rewrite this picture right here, it's going to look like this. Oh, excuse me. I made this a 4 ohm resistor, okay? Now these two are in series, and so our total resistance, according to this picture, is going to be 8 ohms. 8 ohms, okay? So that was the first part. Okay? So I'm gonna draw this picture over here again so we can use it as a reference. So this is the circuit partially broken down. Okay? 4 ohm, and I'm gonna reference it back and forth. Next thing we're gonna do is we're gonna solve for current. We're gonna solve for total current. Total current is gonna be V equals I over our current is going to equal V over R. Voltage here is 16 volts. Total resistance is 8 ohms. So our current here is 2 amps. Okay? We're going to next solve for V1, V2, and V3. And we're going to solve for I1, I2, and I3. So I'm going to call this resistor 1, 2, and 3. Okay, 1, 2, and 3. So the voltage in series, remember, because this 4 is in series with these two, voltage is equal to I times R. So the current is equal to 2 amps. The resistance is equal to 4 ohms. So my current through this resistor is 8. Or excuse me, my voltage through this is 8 volts. Okay? So that's 8 volts going into this one. Now, in parallel, the voltage is going to be the same. The voltage is going to be the same. So, when I broke this down, into one resistor, I can find the current, which in this case happens to be the same thing. 16 volts or I'm sorry. V equals I times R. 2 amps times 4 ohms. So in this case, the voltage for the whole thing is going to be 8 volts, okay? Because it's going to be 8 volts going this way and 8 volts going this way, because we know in parallel the voltage is the same, okay? Now let's look at currents here. Currents here. In a series circuit, the current is going to be the same all the way through. And we notice that this 4 ohm resistor is in series with this one. So if the total is 2 amps, it has to be 2 amps here. So it's going to be 2 amps coming in this 4 ohm resistor. But we know in parallel, the current breaks up. So the current is going to be V over R. Okay? Well, the voltage going into each one is 8 volts. So it's going to be 8 volts divided by 12 ohms for the first one, and then 8 volts divided by 6 ohms for the second one. So 8 divided by 12 is going to be 0.667 amps, and 8 divided by 6 is going to be 1.3 amps. Notice there was 2 amps going into this thing. The amperage broke up and there's going to be 2 amps coming out, okay? Because the current in a series is the same, but it's going to break up in parallel. 0.667 and 1.3 add up to 2, because it was 2 coming in, it breaks up and it'll be 2 coming out. Okay, just like with voltage in a series circuit, voltage splits up, and this is 8 volts, and this is 8 volts. Okay, total to make 16 here. So that was our first example. Of learning how to solve for resistance and current in a series circuit. Notice I had to remember all my rules to solve for this, and power is actually a little bit easier, because once you know all these things, power, you just use one of your equations and it'll work out very easily. The total power is going to be P equals I times V. Well, total current is 2 and total voltage is 16, so it's going to be 2 times 16 is going to be 32 watts. The power through number 1 is going to be 2 amps times V, 8 volts, so it's going to be 16 watts through the first one. Through the second one is going to be 0.667 times 8 volts, which is going to be 5.36 watts. And this one's going to be 1.3 amps times 8 volts, which is going to be 10.64 watts. Notice 10.64 plus 5.36 plus 16, these all add up to 32. Now there is one question is going to be a common question you see in a lot of different kinds of tests. A very common question is which bulb is the brightest? Which bulb is brightest? And the brightest bulb is going to be the one with the highest current. So in this case, it's going to be this bulb is going to have the highest current. The highest current is always going to lie on the main branch, If the branch ever splits up, the current splits up, and so therefore it's never going to be in the parallel. It's always going to be in the series. Okay, so that's a very common question. Which bulb is brightest? The one with the highest current. So let's do another example here, a different one. We have a 7 and 8 ohm resistor. Let's find the equivalent resistance here. Okay, if I draw this picture again, The first thing I would do here is I can't add them in parallel yet. I have to add them in series first. So what happens is I end up having a parallel circuit. Here's my 30 ohm resistor, and here is my 15 ohm resistor because I added 7, 7 and 8. Okay? Okay, so this is my 15 ohm resistor. When I add these two together, 1 over 30 plus 1 over 15 equals 1 over R. I get an R equal to 10 ohms. I'm not going to go through the math on that one. So the equivalent resistance is 10 ohms. The total current is going to be equal, I equals V over R, which is going to be 30 volts divided by 10 ohms, so it's going to be 3 amps. Okay, 30 volts divided by 10 ohms is 3 amps. So we have to now go through and solve the voltage for all three resistors here using our logic and our knowledge of the rules to figure it out. So I know in parallel it's going to be 30 volts going through here and 30 volts going through here, okay? Because in parallel, it's going to be the same voltage for each. So I'm going to call this number 1, this 2, and this 3, okay? 1, 2, and 3. So I know in parallel, the voltage is the same. So through this one, it's going to be 30 volts, okay? That one was easy. I know this 30 volts is going to be split up between these two in series. So the voltage in series is equal to the current times the resistance in series. But I don't know the current yet. I don't know the current through this one yet. So we have to figure that out next. Okay? So let's go back. The current through number 1 is going to be equal to V over R. V over R. So 30 volts over 30 ohms is going to be 1 amp. Okay? 30 volts over 30 ohms is 1 amp. The current in 2 and 3 is going to be the same. The current through 2 and 3 is going to be the same because it's in series. So it's going to be 30 volts going in, divided by 15 ohms because these two are in series, okay? It's going to be the same because they're in series. So I get 2 amps here. 2 amps, 2 amps. Now that I know the amps, I can now solve for the voltages of these two, okay? V equals I times R. 2 amps times 7 ohms is going to be 14 volts. 2 amps times 8 ohms is going to be 16 volts. Notice 14 and 16 add up to 30. Notice that we have 2 amps going in this way, we have 2 amps coming in this way, and 1 amp going in this way, which adds up to our total of 3 amps. So notice how all of our rules are starting to come together. The voltages in series add up to the total. The current in parallel add up to the total. Okay? Very important to know these rules here, okay? And if we do power, P equals I times V, the total power is going to be 3 times 30, 90 watts. P1, P2, P3. I times V, 1 times 30 is 30 watts. 2 times 14 is 28 watts. And 2 times 16 is 32 watts. All these add together equal 90. Lastly, I would like to give you one more common question, and that is this. It is very common to say which circuit dissipates more power, or uses more power, uses more power. And the circuit that dissipates more power is the one that has the least resistance. The circuit that dissipates more power is the one with the least resistance. So let's just say, for example, I know it changes all the numbers up, but let's just say that this was a 30 volt battery. Everything else is the same. The total resistance here is 8 ohms, and over here, the total resistance is 10 ohms. If I looked at just those two numbers by themselves, the one with the least resistance would be the one with the most power. So that's once again another common question. Okay, obviously, once again, if we made this 30 volts, it would change all these numbers up. But let's just say it's 30 volts. We have two circuits. The one with the least resistance gives us the most power.